let's go through this algebraically. So here we have our camera, which has some viewing direction, all right? And the viewing direction is not going to matter because we're going to assume a Lambertian system, which is what we have here. We assume that it's just proportional to the cosine of the incident angle between the light source and the normal. But the idea is that the camera is fixed. And for each one of our sources, source 1, we take our first image. Source 2, we take our second image. Source 3, we take our third image. Now notice, by the way, that rho is in these equations, right? Rho is the albedo, so I'm not assuming I know the albedo. So now I have 3 images. Right? And I can write these as a matrix equation for, this is for a single pixel, right? So at a single pixel, I would have 3 different values, and I could just write this equation as rho, and these are the 3 vectors that are the source directions. And by the way, I assume I know the source directions, times the unit normal, and the unit normal is the thing that I don't know. So I need to solve for that, all right? So remember, we're making this Lambertian assumption. So solving those equations is straightforward. It's linear. It's a simple linear system. If we have 3 lights, I is our 3 measurements, 3 intensities. S are the 3 directions to the light source, and we know those, so I and S are known. And then, as we said before, N is supposed to be unit normal, rho is the albedo, so together I call them N tilde. So to solve for N tilde is trivial. N tilde is just S inverse I. But of course, N tilde is not a unit normal. In fact, its magnitude is what? Its magnitude is the albedo, so I can solve for rho, the albedo, and I can solve for the unit normal as well by just taking the magnitude of that. Now, of course, that's with 3 lights, and anything that works well with 3 lights is going to work better with more lights. So let's suppose we have more lights, like m of them. Well, we get the same set of equations, but now we need a least squares solution because the system is over-constrained, and basically solve it here. So m by 1 is the number of measurements we have, and so we have to take the pseudo-inverse. And the pseudo-inverse will give us the least squares solution for N tilde, and then again you can find the albedo.